Okay, let's get right into it. My lecture is on memory. That's chapter 4, section 4.2. We're going to start with a brief overview and then get into how memory changes as we age. Let's begin with just a definition of memory, right? If you look back to page 103, you're going to find the general consensus. Memory is our ability to recall stored information when needed, but it's not quite that simple, right? There's a dynamic component that humans exist in differing forms, and memory is in constant flux throughout our journey of adulthood. Notice the comic there, right? The therapist says, let's start with your earliest memory. And the guy says, yesterday I had a tuna fish sandwich. So maybe his episodic memory is not so strong. Within the fundamental science of memory, there's a consensus of how memory works, and that's according to the information processing theory. And no one scientist claims to have invented this model. However, it seems like it was redefined or refined in the 60s by Atkins and Schifrin, 1968 paper they did. Basically, it takes our brain and analogizes it to a computer, how our memory works. Initially, you will have the sensory store, where you have your visual and auditory information. It's held for just a couple of seconds before it moves on to the second stage, where you give it attention. That would be known as the short-term store, right, the second step. And beyond that, you can encode it into the long-term memory, which is your final destination for memory and where you hold it for years. And there's a symbiotic relationship between short-term memory and long-term memory working together, so you can put things from your short-term memory into long-term and then retrieve it back from your long-term into your attention as the short-term memory. So as I said at the beginning, right, memory is pretty complex, and within your short-term store you have subtypes of memory, right? So initially you have your primary memory, often referred to as short-term, and that's your ability to hold information usually for short amounts of time. And contrast that with your working memory, which is your ability to hold the information while you're conducting an operation with that information. And that is a central component of executive function, which is the process of regulating your attention and determining what to do with either new information or information from your long-term storage. So for an example for primary memory, I'm going to go ahead and give you a string of numbers, okay? So 1, 6, 8, 3, 4, 1, 3, 7. Now repeat those numbers aloud. You may have not gotten all of those, and that is an example of your primary memory, how you can hold on to information in the mind for small amounts of time, and it can be pretty mundane or arbitrary. Now if you were to add those numbers up, that would be an example of working memory. You're taking that information while conducting an operation on that. And if you're wondering, the answer is 33. All right, moving forward into the different subtypes of your long-term storage, as opposed to the previous slide on our subtypes of short-term storage, we are looking at declarative memory, often referred to as your explicit memory, and non-declarative memory, which is known as your procedural memory, and last, perspective memory. So declarative memory is represented in two ways within the long-term storage. You have your semantic memory, which can be understood as our accumulated knowledge throughout our lives, such as facts, ideas, or concepts, and your episodic memory, which is our ability to recall events or past personal experiences. It is the who, the what, the when, the where, the why, right? The memories of our lives. If you remember that comic at the beginning, he said he had a tuna sandwich and that was his earliest memory. Pretty poor episodic memory, right? So an example of semantic memory, if I say the word blue, you can generate a mental picture of the color blue. In other words, you understand the concept of the color blue. Whereas with an episodic memory, I can ask you, for instance, what did you eat for breakfast this morning? Most of you can probably recall that episode in your lives. You can recall the what, the when, the where, and the why of that part of your life. Next, we have your non-declared memory, which basically guides our body as our minds unconsciously recall procedures. Okay, so when was the last time you considered how to use a can opener? You probably already know how to use a can opener, and it's implicit within your memory. Okay, you don't have to actually consciously think about it. And there was actually a study done on this, and I don't remember all of the details, but they take top tennis players like Serena Williams, and those players use much less brain power to play tennis than did novice players. The novice players required a lot more attention to what they were doing to do it effectively. So tennis is deep within these top tennis players' non-declarative memory. Okay, and prospective memory is to think of a task to do in the future, right? So if you have to pick up the kids from soccer at 6 p.m., that's your prospective memory. It's a prospect of the future, something you're going to have to do. That's part of your storage. All right, moving. Here I've provided a diagram just to encompass how the human memory system works. If you need to pause the video to take a little bit of time to review it, I think it kind of helps to have a visual aid of the, kind of the hierarchical setup of memory from sensory store on to short term, the symbiotic relationship from short term to long term and back to short term, as well as the subtypes below each. So take some time there to review, and if you need to go back to prior slides to kind of catch up, because after this we're going to be moving on to how memory is in constant flux over age. It's very dynamic, and you'll see some interesting things to come. Well, since this is the class on the journey of adulthood, let's take a look at memory as we age. Now, if this graph looks familiar, that's because hopefully you read it and I scanned it from the text. But do you notice a trend taking place? Short-term memory, long-term memory, working memory, and even the speed of processing all declined from their peaks in our 20s into our 80s. The only one that transcends this is our verbal knowledge, which from our 20s gradually increases all the way into our 70s before taking a small decline into our 80s. Now, there are many theories as to why this may take place. One theory, for instance, is that as adults age, they don't have the mental energy or attentional resources that younger people do, leading to these declines in memory components. Another theory is that older adults may undergo a decline in processing speed, as you can see from the graph, but they may account for this loss in processing speed with more strategy use, right? Because as you get older and more wise, you see patterns in how to solve things, whereas maybe younger adults who can process information quicker throughout their memory systems may go through some trial and error process to find answers. Another hypothesis is that as older adults may have trouble inhibiting irrelevant information, so the system gets gummed up, if you will. They don't know which information to pick and sort throughout their resources coming in. So what I found most interesting is that during brain scans mentioned in the text, older adults performed comparatively with younger adults when the task was simple. In other words, the memory load was small. So maybe they were using strategy use thinking to maintain similar scores, noticing patterns from previous parts of their lives, as compared to the younger counterparts who are using different strategies, in other words, more processing speed, relying on that more heavily. But when the memory load was greater, younger adults outperformed the older adults. And an explanation quoted from our text is that this pattern of neural activation suggests that older adults are not the passive victims of a deteriorating brain, but rather are developing alternative neural strategies to maintain their level of cognitive performance. So, in layman terms, basically they're using strategy use, which comes from different parts of the brain, as compared to younger people who maybe just be relying on, like I said, quicker processing speed. But as I said before, right, working memory is central to executive function, which is the process of regulating attention and determining what to do with either new information or information from long-term storage. Now, this is so critical in our lives. It is very important as to select and successfully monitor behaviors that are going to facilitate the attainment of our goals. That is what executive function is. And what we see is each of these skills tends to decline in their efficiency as we age into older adulthood. So here we have another very informative graph from the text. Now this one focuses on trends in both episodic and semantic memory. If you remember, episodic memory is our ability to recall events of past personal experiences that are unique to us. It is the who, the what, the when, where, and why of the memories of our lives. Meanwhile, the semantic memory is our accumulated knowledge throughout our lives, such as facts, ideas, or concepts. I think the most interesting data from the graph is how semantic memory abilities show increase through middle adulthood, while episodic memories, they take a sharper decline by about the mid-60s. Now, they do provide a hypothesis to this, and that is that older adults may have greater difficulty forming associations between episodic memories and retrieving them from their long-term stores. So that is, like, it is easier to remember events if they're tied together, right? And another reason is that episodic memory requires greater specificity. So in other words, remembering specific details from events, whereas semantic memory relies more on remembering concepts and ideas. If you remember back the concept of blue, I mean, you have an image of blue in your head. It's very general. So this may be why there's more decline in episodic memory compared to semantic memory as we age. Thank you for listening to my presentation of memory throughout the journey of adulthood. I appreciate any feedback y'all can give, and I appreciate all of you.